Hey everyone, thanks for joining in. We've got 2 more minutes and we'll get started as soon as we have more people in the room. So we'll get started in about 2 minutes or so. So please hang in there. Thanks. All right, so let's get started. So good morning, good afternoon, good evening, everyone, depending upon where you're joining in from. My name is Rahul and welcome to our webinar today on tackling and defending Kubernetes. Before we get started, I hope everyone is safe. I know these are very testing times. I hope all of you are safe and secure at your place. And thank you all for taking your time for joining on this webinar. I just sincerely hope and pray that things get back to normal and all of us can be back into what we're doing better. So let's get started. So today's webinar is going to be delivered by my colleague Nitin. So for those who've been regulars at the OWASP conferences or the Black Hat conferences, you probably would have bumped into him. But Nitin just finished doing a series of talks and workshops on this very topic across various conferences across the globe last year, and fortunately earlier this year before most of the conference circuits got shut down. But then I thought it'd be good for us to start off we45's 2020 webinar series with this particular topic, because we've kind of been seeing a lot more traction amongst our customers in terms of people who've just been curious, people who are working on Kubernetes, people who have taken it, people who are considering adopting it in the next couple of months to a year. So yeah, I mean, this is one of those webinars that have a lot more content. So Nitin has specifically told me to keep the introduction short, so we'll get started immediately. There would be a question and answer session at the end of the webinar. So you have the chat screen at the bottom of your webinar, this webinar controls that you should see. So please go ahead and submit your questions there, either in the Q&A section or in the chat section, and we'll get to it at the end of the webinar. So with that, I'll hand over the controls to Nitin. Take it away, Nitin.
Hey, thanks a lot, Rahul. Hey, welcome everyone. Welcome to Attacking and Defending Kubernetes. So in this webinar, we're going to go ahead and start attacking a Kubernetes cluster directly. So what I've done is I've set up a complete Kubernetes cluster from scratch. So I'm not using your typical GKE or EKS. I've set up my own Kubernetes cluster. We're going to go ahead, deploy applications on it. And then we're going to look at ways to attack it, and later we're also going to learn how we can go ahead and secure it. So with that, my name is Nitin Joyce. I'm a senior security solutions engineer at we45. I mostly handle DevOps, and I also help most of our clients implement DevSecOps in their organizations as well. So I'm a co-lead developer of an open source project called Threat Playbook. So we have been making quite a few changes to this particular in the recent past, and we are releasing a bunch of updates very soon as well. So Threat Playbook essentially helps you threat model with code, right? So instead of your typical whiteboard approach, you can start threat modeling with code. And I'm also a code developer of Orchestron. You can find it on orchestron.io. So Orchestron is a vulnerability management and a correlation platform. Once you implement DevSecOps, one of the initial hiccups or the issues that you will run into is managing results from various tools. And a tool like Orchestron helps you do that. I am also a trainer and speaker at multiple security events. I've delivered trainings at OWASP conferences, multiple conferences in Singapore, Japan, and at Black Hat as well. So with that, let's get started. So this is the agenda for today. So first, we're going to quickly go ahead and compromise a Kubernetes cluster, right? So in this particular attack, we're going to deploy a vulnerable application onto our Kubernetes cluster. From that particular vulnerable application, which is running on a pod, we're going to pivot the attack and then gain complete access to the Kubernetes cluster. So once we're done with the attack, we'll quickly analyze how the attack happened, what were the mistakes that we made, and then we're going to jump into the Kubernetes security model. We'll look at the workflow about what are the steps that you need to take in order to implement a good security measures in your Kubernetes cluster. Once we're done with that, we're going to look at auditing our Kubernetes clusters. Finally, we're going to look at a few tools in vulnerability assessments to ensure that our entire cluster is secure. And once we're done with that, we're going to, combine all of this together, and we're going to run a very security-specific CI/CD pipeline. So this is going to have the scanning bit. It's going to scan your application. It's going to build a Docker container. It's going to package everything, and it's also going to deploy to the Kubernetes cluster as well. So with that, let's get started with Kubernetes, right? So for those of you who are not aware, so this is the high-level overview architecture diagram of a Kubernetes cluster. So as an end user, you are mostly talking to the API only, right? So you can either do it from a user interface or using a tool like kubectl, and you can communicate with the API using the kubectl as well. So there is something called the master component, and there are also nodes. So as a user, you are mostly communicating with the API server component, and that is going to handle all the communication with rest of the nodes or your worker servers. The scheduler is a component inside the master component itself, and this is going to be responsible for scheduling all of your pods and all the deployments onto your nodes. Your controller takes care of your service accounts, the user management, and finally, the etcd is the data store or the database where all the configuration files are stored inside your Kubernetes cluster. So even if you have approximately, let's say like 30 nodes, right? So as an end user, you do not have to communicate with all of these 30 nodes necessarily. You just communicate with the API server or the Kubernetes master, and that's going to handle the communication with all of your nodes as well. It's going to take care of deploying resources across all of your nodes. So before we get started, I thought it was important for you to be familiar with some of these terms. So when we speak of a cluster, it is a collection of worker nodes and the master component itself. So the master component along with all of the nodes is essentially a Kubernetes cluster. A node is a worker machine. So this can be your virtual machine. It can be an EC2 instance or any other VM for that matter, right? So you can have your own, for example, you can have your own laptop connected to your Kubernetes cluster as a worker machine if you want to. So a node is nothing but a worker machine. A pod is the smallest object in Kubernetes. So in Kubernetes, you're not deploying Docker containers anymore per se. You can combine multiple containers, or you can even deploy a single container, but this is called a pod in the Kubernetes lingo. And finally, we have something called deployments, and this manages the replicated applications, right? So for example, let's say we deploy a web application, and all of a sudden we see a huge spike in traffic. So as soon as there's a spike in traffic, we want to create replicas so that it's load balanced across multiple servers. So we go ahead and create a deployment and ask it to go create replicas, and that's going to take care of load balancing for us. And finally, we have something called service in Kubernetes, and this is how your applications are accessed inside the Kubernetes cluster and outside the Kubernetes cluster as well. So there are multiple services. We have something called the node port, the cluster IP, and the load balancer as well. So we'll quickly look into some of these when we are running our lab as well. So with that, let's look at an attacker's view of Kubernetes, right? So this is an extremely high-level threat model of a Kubernetes cluster. So one of the key attacks that can happen is a malicious user compromises the cluster. And this is where things like role-based access control and attribute-based access control or even implementing something like open policy agent with your webhooks is going to be extremely important, right? So you want to be sure that the attack surface from within is restricted as possible, and the restrictions to particular users are available as well. Finally, we have malicious app or a container that can potentially compromise the cluster as well. And this is something we're going to be seeing in our attack very soon. So just because you are deploying your containerized application to a Kubernetes cluster, it does not necessarily mean that you do not follow AppSec 101, right? So even if you are deploying a malicious application onto a cluster, your cluster can still be attacked and bound. Finally, we have a malicious node that can compromise a cluster as well. So as an attacker, what I can potentially do is I can connect a machine or a worker machine that I control as a node to the Kubernetes cluster. And using the kubelet component that is available inside every node, I can then start communicating with the master component and then pivot my attack in order to gain access to the entire Kubernetes cluster. So when you're running Kubernetes, there are multiple services that you have to look out for. So in the kubelet component that we just spoke of, there are 3 ports, that is 4149, 10250, and 10255. Be sure to check for these ports regularly and ensure that there is some amount of authentication and authorization that is necessary in order to be able to communicate with these ports. Finally, we have the kube proxy runs on 10256. If you're running Calico, it runs on 9099. And finally, the kube API server. So this is what you'll likely be communicating with, the port 6443. And that is the API port that you will be communicating with, especially if you're using the CLI interface that is kubectl. With that, let's look at a demo of attacking a Kubernetes cluster, right? So I'm just going to navigate to the Kubernetes cluster attack directory. So in this server, I have a Kubernetes cluster setup. So if I say something like kubectl get pods across all namespaces, it's going to list out all the pods. It's going to list out all the services as well. So if I want to look at all the services that are on my cluster, it's going to list out all the services and the pods that are running on my cluster. So with that, I'm going to navigate to the Kubernetes cluster attack directory. And then I'm going to create a cluster role binding. So I'm quickly going to talk about this right now. So in this particular command, what I'm doing is I'm creating a service account named bad boy, and I'm giving that particular service account complete admin level privileges to the Kubernetes cluster. And this is an extremely bad practice, and we're going to soon see why that is. So now I'm going to fetch pods. Since I have nothing deployed on the default namespace, it's going to return with empty. So first, I'm going to go ahead and set up my Flask stack, right? So I have a bash script right here. So first, this is going to create a config map for my Nginx configuration file. Then I have a deployment file, which essentially creates the deployments that we spoke of. And finally, it's going to create a Redis service and a Redis service pod and a Redis service as well for me to be able to access this particular Redis database. So in this particular example, I am deploying a Flask application, and which uses the Redis database as a backend database, right? So all the information that is going to be stored. This is a payment management system. So all the information is going to be stored onto Redis database. So by running this bash script, it's going to execute all of these commands for me, and it's going to set up all of the necessary resources. So it's going to deploy my Nginx pod. It's going to deploy my vulnerable Flask application, my Redis database as well. So if I say kubectl get pods, and all of these are being deployed on the default namespace. So it's going to tell me that all of these containers are being created. If I look at services, it tells me that these services are currently ready as well. So I'm going to give it a few seconds. I'm going to go ahead and check the pods. And all of these pods are currently running. So I'm just going to go ahead and move on to my next set of commands. So now I have my ng flask, as you can see right here. I have my ng flask application that's running on this particular cluster IP on port 80. I'm just going to set that particular IP address as an environment variable to make it easier for me to run the subsequent commands. So I'm just going to set it as the ng flask. And if I echo it, it's going to return back with the same IP address, which is the cluster IP address. So Sanu, since this is an API application that is running, I'm trying to do the get on the application. So it's going to respond back saying, please post a JSON request to this particular URL. So now I'm going to create a few artifact transactions. And once these 10 transactions have been generated, I'm going to fetch the status of these transactions as well. And it's going to give me with a truncated credit card number, name, and the expiration as well. So I have set up an application that is storing some of these credit card numbers in the Redis database. And my goal as an attacker is to gain access to this credit card information in plain text. So now I was able to fetch the status successfully, and I'm going to navigate to the payloads directory. And in this particular example, or in this particular vulnerable application, we are vulnerable to something known as insecure deserialization, right? So using that particular payload, I'm going to go ahead and post a payload called test_payment.yaml. So if you look at that particular file, it's going to essentially try and execute the print env command on the pod that is running the application, right? So it's going to go ahead and upload this malicious file. And once this malicious file has been processed, we're using an insecure library of yaml.load. So ideally, you should be using something called yaml.safeload. But in this particular vulnerable application, we're using the yaml.load feature, which is vulnerable to insecure deserialization. So I'm going to go ahead and post this I'm going to upload this particular file. And once it is done, if I check the status again, if I check the status of the payment again, it's going to print out all of the environment variables inside my particular pod. And if you look closely, this already has quite a few sensitive information that is available. It's for an attacker, it's going to tell him or her where that particular master component is running, where Redis is running. All of that information can be gathered by just printing the environment variables, and all of this information is stored as metadata inside the pods. So now I was able to fetch the status again. So now I have another payload called the reverse_shell.yaml. I'm going to append my IP address right there, and now we're going to look at it. Right. So right here, this is a single line reverse shell executable, right? So we're using Python, and using the socket and sub process, we are connecting back to a listener that is supposed to be running on port 1337. And this is going to give us a reverse shell access to our listeners that we have to set up. Right. So before we go ahead and do that, I need to set up a listener. So I'm going to use the netcat command on another screen right here. So I'm going to listen on port 1337. So with that, I'm going to upload my malicious reverse_shell.yaml file. And if this attack actually happens in my listener right here, I should get reverse shell access to the pod that is running this particular vulnerable application. So I'm going to post this reverse_shell.yaml. And once it is done, if I go back to my other terminal, I now have reverse shell access to my pod that is running this particular vulnerable application. And I also have access to source code and this entire particular pod that is running. So one of the interesting features that Kubernetes has, especially when an application or a pod is being deployed with a service account, is that it stores the credentials and the certificate of the service account inside every pod that service account is deploying. right? So if we navigate to run secrets kubernetes.io and service account and list out all the files, we have the certificate, we have the namespace. So since we are in the default namespace, it's going to tell me that it's default. And I also have the token of the service account that deployed this particular pod or the deployment to my Kubernetes cluster. So if I say cat token, I have the GAWT token right here. So now 100% of Kubernetes is API, right? So this is something extremely important that you have to remember. So you do not necessarily need your kubectl or your UI even. You can start communicating with an entire Kubernetes commands with just curl commands, right? So you can use simple curl commands to communicate with the entire Kubernetes cluster. And that is exactly what we're going to do right now. I'm going to store this token as an environment variable, so I can use it as a reference in my curl commands. And with that, I'm going to start, fetching I'm going to list out all the pods present on my Kubernetes cluster. So as an attacker using the stolen token, I am now able to list out all the pods. I can see the environment variables that the pod is using and everything else, right? So I have complete access to all the pods, the environment variables. So if a secret is stored as an environment variable, I have access to all of that as well. So using these curl commands, I'm now going to pivot and start gaining access to the rest of the resources as well. So I see that Redis is running. So I'm going to fetch the IP address where Redis is currently deployed inside the Kubernetes cluster. And I know for a fact that Redis is now running on this particular IP address. And I'm also going to fetch my server IP. So this is the server IP where I have my listener and setup as well. So with that, I'm going to deploy a malicious Redis pod. So the way Redis works is Redis can have a master component and also something called a slave component, right? So what I'm essentially doing in this particular line right here is I'm going to deploy my own malicious version of Redis. I'm going to ask it to attach itself as a slave component to the main Redis database. It's going to steal all the data from the Redis server, and then it's going to finally start posting all of the stolen data to my listener that I'll be setting up. So I have all of this information copied right here. I'm going to replace some of the values. So I'm going to replace the value of the server IP as the listener IP right here, and also that of the Redis IP. So when you're deploying resources onto your Kubernetes cluster, it does not necessarily have to be YAML specification files. It can also be defined as a simple JSON file as well. So I'm going to copy this particular command and I'm going to run it in my reverse shell right here. And this is going to throw me an error, right? So it's actually going to throw me an error and it's going to tell me permission denied. So even though I am the root user inside this particular pod, I still do not have the permissions to go ahead and create files in this particular directory. So I have to navigate to the /temp directory and I have to run this command again. So I'm going to copy this command and I should have the mal-redis.json right here. So using the curl command again, I'm going to launch or create this malicious Redis file. So it's going to tell me that the status of this malicious Redis file is currently pending. And I'm going to navigate on my actual server. I'm going to navigate back to my attack directory and I'm going to run a listener. So the way this is going to work is my malicious Redis file. It's going to fetch all of the information from the main Redis database. It's going to attach itself. It's going to steal all of this information. And then it's going to start pushing all of this information to the listener that I've just set up every 10 seconds or so, right? So as you can see right here, I now have access to all of the credit card information in plain text. And this is going to be happening every 10 seconds. So anytime there's a new data entry, we still have complete access to all of the resources and we can start stealing all of the data as well. So it's going to keep posting all of this data. So now I'm going to exit from the listener. I'm going to navigate to the cluster component, and I'm going to delete all of the resources as well. I'm going to delete all the deployments. It should also delete the reverse shell that I had set up. I'm going to delete the malicious Redis pod that I had created, and also the nginx config map that I had previously created as well. So this was quite a comprehensive attack, right? So there were definitely a lot of moving parts. So with that, let's look at some of the observations of this attack. So there are multiple layers where things were wrong, right? So in the application layer, first of all, we were running a vulnerable application that was vulnerable to insecure deserialization. And when it comes to secret management, we were essentially storing all of our secrets as environment variables. I understand that managing secrets in Kubernetes can be hard, but there are a lot of options like Vault, Camus, and multiple other options that you can start using. And finally, Redis by default does not have authentication, and we were using Redis in the default mode without any authentication. So in our application layer, these were some of the flaws. In our container layer, we were running the entire container as root. So ideally, you should be running all of your containers or pods as non-root or with the user ID that is not equal to 0. We did not have any container runtime hardening as well, right? So we were not using any AppArmor or SecComp profiles to prevent some of these attacks. And then again, insecure secrets in container environment variables. So we were able to list out all the environment variables and steal information. And using that information, we were able to, launch our own malicious pods on our Kubernetes cluster. And finally, in our cluster layer, we had no network policy at all. So ideally, you should be blocking most of the egress traffic that is going outside from your Kubernetes cluster. There is no authentication or access control in place. And we were not using namespaces, right? So everything was running on the default namespace. We did not have any pod security controls, and there is absolutely no monitoring on our Kubernetes cluster as well. So with that, let's look at the security model that you have to implement if you want to secure your entire Kubernetes cluster. So this is the ideal security model that you typically have to follow when you're trying to secure your Kubernetes cluster. So when it comes to setting up a Kubernetes cluster, try and restrict access to the kubectl and try and leverage something like role-based access control for all of the users and all the groups that are inside your Kubernetes cluster. Try to leverage role-based access control. You definitely use network policies. You can start implementing, if you'd like, Istio and multiple other things as well. So once you're done setting up a cluster in a secure manner, you can then start following the security hygiene, right? So make sure that your Kubernetes is up to date. Make sure that all the operating systems or the base operating systems that you're using are minimal. Private IPs for all of your nodes, try and ensure that there is virtual, all of your nodes are inside a VPC, and make sure that everything is being audited and logged as well. And once you're done with that, you can start preventing some of the known attacks. So this will be disabling dashboard, try and disable the default service account token as well. And that was one of the main reasons our previous attack did happen, right? So we were deploying all of these containers with a service account token that had admin level privileges. And especially if you're deploying in a continuous manner, if you're using something like Jenkins or Travis CI or even GitLab, and if you're using a service account, try and minimize the roles that particular service account has access to, right? So the service account should ideally should not be allowed to delete pods and delete some of the services, but should only be allowed to deploy. And finally, scan all the images for known vulnerabilities. So we will be looking into scanning images as well. And once you're done with that, finally set up your pod security policies, protect your secrets, have your own secret management solution in place, try and protect your secrets, and consider sandboxing your environment as well. So when it comes to authentication and access control, there is authentication, access control, and admission controller in your Kubernetes as well. So in Kubernetes, there are two types of users. So one you have is the service accounts that we just used. And these service accounts are typically managed by Kubernetes itself. And these are most often used by services. And then you have normal users. This is managed by an outside service. So the user typing kubectl must authenticate and must not be an anonymous user, right? So ensure that you have particular role-based access controls in place. And this is the service account that we just used, right? So you can create something called a service account for the services that need to access your Kubernetes cluster. So an example that we have right here is a Jenkins is going to build an image, and it's going to deploy that particular image to a staging namespace. And the way Jenkins is going to deploy that image is by using a service account. It's going to authorize itself onto the Kubernetes cluster as a service account, and then it's going to deploy onto that particular staging namespace. So service accounts typically use JSON Web Tokens and are signed using the certificates that we just saw. One thing you have to understand is there is a clear separation between authentication and authorization. So the first step is authentication. Obviously, just because a user is authenticated onto your cluster or onto any other resource, it does not necessarily mean that they are authorized to perform certain set of operations. And when it comes to authorization in Kubernetes, there are multiple ways of implementing it. So you can have a node level authorization. You can implement something called the role-based access control. You can implement attribute-based access control. Or if you want to really scale, what you can do is use a combination of webhooks and open policy agent. And it's going to be a lot more scalable as well. So with that, let's look at role-based access control. So the way this works is you define a role and then you attach a group of users or a set of users to that particular role, and that is called role binding. One thing you have to understand in Kubernetes, and this is kind of very similar to AWS in the front, is permissions are additive in nature. So if you want a group of users or a certain user to have access to something, you have to add that particular command to ensure that user has access to whatever they need. So this is relatively easy to manage, especially if you have clearly defined set of privileges for all of these roles. So if you want to create a role for one particular namespace only, you would create a role. If you want to create a role for multiple namespaces, you would create something called a cluster role. So with that, let's look at an example of role-based access control. So first, I'm going to navigate to the role-based access control directory on my Kubernetes cluster. I'm going to generate a SSL key. And then I'm also going to generate a certificate using the key that I just created. So now I'm going to generate a self-signed key for Kubernetes within the cluster certificate authority itself. And I'm going to go ahead and create something called a restricted namespace. So if I say kubectl get namespace, it's going to list out all the namespaces that we just created. And it's going to tell me that the restricted namespace was created 5 seconds ago. Now I'm going to create a user called the restricted user, and I'm going to use that as a context, and I'm going to attach this particular restricted user context onto the restricted namespace. So now I have a restricted user, I have the restricted namespace, and I have the context set as well. So kubectl by default has something called CANI, and using CANI, you can check if you have certain set of privileges or if you have access to a few resources onto your Kubernetes cluster. So using the restricted user context, I'm going to ask the Kubernetes API if I can get the pods, and it's going to return back with a response saying, currently, no, you do not have the permissions to get pods. And if I try and run the get pods command, it's going to throw me a permission denied or a forbidden error. So now what we need to do is we need to create a role and a role binding. So right now what we're doing is we're creating a deployment manager role. So I'm quickly going to open that up and we're going to have a look at that. So in this role, we have access to the following resources, right? So we have access to deployments, pods, and services and replica sets as well. And these are the verbs that this particular role has access to. So this role can get, list, watch, create, update, and patch all of these resources. And one thing that you will observe is the verb delete is not available right here. So this particular role does not have the ability to delete some of the resources on the restricted namespace. So I'm going to create, this has already been created. So I've created a role and now I have to bind this particular role to the restricted user, right? So which is what I'm going to do with this command. So I'm going to create something called a role binding. So in this example, I'm using the user restricted user and I'm binding that particular user to the role deployment manager role that we created in the previous step. So now using the restricted user context, I'm going to fetch if I can get the pods, and it's going to return back with a response saying that I now can get pods. So in our previous command, we were not able to get pods. That was because we had not created a role or a role binding. So now that we've taken care of that, we now have the permission to get pods. And we also have the permission to create pods as well. So with that, I'm going to create a Nginx Alpine pod as a restricted user. And I'm going to check if I can delete pods as the restricted user, and it's going to return back with a response saying, no, you do not have the permissions to delete pods. And if I fetch all the pods that are running in the restricted namespace, I see that Nginx is currently running. And if I try and delete that as the restricted user, it is going to throw me a forbidden error telling me that I do not have permissions to delete anything on the namespace. So in order to delete all of the resources, I just delete the entire restricted namespace, and it's going to delete the role binding, and the pod that I just deployed as well. What you can, so this can be quite scalable as well, especially if you create groups. So your developers are going to be in a separate group, your ops folks are going to be in a separate group, and your security engineers are going to be in a separate group. And all of these groups can have particular roles attached to them that clearly define what that role has access to. And then we have something called attribute-based authentication system, right? So this is a simple JSON mapping of users and specific resources that user has access to. So in this example right here, we have a user named Alice, and Alice has access to all namespaces across all resources on all API groups, right? So this particular user, Alice, she has access to everything, almost everything on the Kubernetes cluster. So Alice has access to the namespaces and the resources in the cluster. So now let's look at another example of Bob, right? So Bob, the user Bob, has access to the OAuth namespace only, and the resource that Bob has access to is pods. So Bob does not have access to any other namespace, and Bob cannot list the services even. Bob can only list the pods since it's read-only true, right? So Bob cannot even create pods if he wants to. With that, let's look at pod security policy, right? So pod security policy is a rule set that defines specific rules for a pod that is being run in your Kubernetes cluster. So this is actually optional. It is highly recommended, but you do not necessarily have to use it. And this is an admission controller that has to be enabled on your API server. So the way this works is even before your resource is allocated, as soon as a request is hit, this admission controller is going to look at the request. It's going to see if it follows all of these defined rule sets. And if it does, only then it's going to allow the particular resource to be loaded. If it does not, then it's going to deny that resource from being spawned on the Kubernetes cluster itself. So there are quite a few parameters in pod security policy. You can have unprivileged or privileged containers. So if your pod is running with the 44 block syscalls, by default, if you're using the privilege flag, you can set that to false and ensure that any pod that is being deployed on your Kubernetes cluster cannot be privileged. You can also set in Linux capabilities. You can also start implementing AppArmor and SecOm profiles as part of your pod security policy as well. And finally, you can allow or disallow privilege escalation. So if an attacker wants to run something like the sudo command on your Kubernetes inside a pod on your Kubernetes cluster, you can start disallowing all of this and ensure that the overall blast radius in case of an attack is as minimal as possible. So pod security policy is something that is highly recommended. So this is an example pod security policy where we're using the Docker's default AppArmor and the Docker's default SecOm profiles right here. And we're dropping all of the capabilities by default. And we're also saying privilege is equal to false, and also allow privilege escalation is false. So if an attacker tries to escalate the privileges inside a pod, it's going to throw an error. And finally, you can start having rules as well, right? So one of the interesting rules you can have is must run as non-root. So if your container or if your pod is trying to run as a root user when it's spinning up, a pod security policy like this, it's going to deny that container or that pod from even being spin up inside your Kubernetes cluster. So with that, let's look at a quick demo of pod security policy. So first, I'm going to navigate to the pod security policy directory. And so this is the pod security policy I have in place, right? So I have the Docker's default SecOm profile, and I'm also going to load my own version of AppArmor profile that is going to be a Kubernetes Redis AppArmor. So I'm going to load that particular AppArmor profile. So this is the AppArmor profile that I'm trying to load. So I'm actually going to launch the same set of vulnerable containers that I did in our attack scenario, and we're going to try and redo the similar attack, right? So it's going to deny write access to the app directory. It's going to deny write access to the temp directory, read, write, execute. All of these permissions are going to be denied to etc password and etc shadow inside my pod. So first, I'm going to load this particular AppArmor policy. And once that is done, I'm going to create the configuration map. So if you remember, we did this in our previous attack scenario as well. And then I'm going to launch the secure variant of my ng Flask. So I'm going to go ahead and launch this particular deployment. So once it's done, I can fetch all of the pods that are currently running on my Kubernetes cluster. And it's going to tell me that all of the 3 containers within this pod are successfully running. So now if I try and exec, or if I try and access the runtime of this particular Flask application, I am able to, I can list out all the directories. But if I try to create the shell.py, so shell.py was what was essentially used in our reverse shell.yaml. So it would create a shell.py and execute Python shell.py. So if I try to create shell.py, it's going to throw me a permission denied error. And if I try to read etc password, it's going to throw me a permission denied error as well. So pod security policy can be extremely effective in especially reducing the overall blast radius in case of an attack. So, but one thing you have to remember is pod security policy is not a silver bullet. It's not going to protect you from network layer attacks, for example. So like I mentioned before, so using your AppArmor or SecOm, it's not necessarily going to protect you from network layer attacks if your application is vulnerable to something like it. And if you're thinking of using a SecOm profile, profiling all of the syscalls that your application uses can be extremely challenging, right? So every time there's a new feature or every time there's a small change in one of the functionalities in your application, the syscalls change along with the application as well. And one thing that can potentially happen is if you block one syscall, it can end up blocking a functionality for another syscall and your entire application might break. So you do not want that happening. So using something like a SecCom profile can be extremely challenging. So AppArmor is an relatively easier approach. And finally, this still does not protect you against your network layer attacks. So with that, let's look at auditing Kubernetes, right? So when you're auditing your Kubernetes API component, these are some of the most important questions that have to be answered. So you have to, your audit logs have to answer what happened, when did it happen, who initiated this particular request, and what resource did this request happen on? So was it on a pod? Was it on a service? Was it on a deployment? Was it on a load balancer service? And where was this observed? And you also want to know where this particular request was initiated, and finally where this essentially request was going as well. So this is an audit policy that can be used for in the request response level. So there are multiple levels that you can capture all of this information. So you can create a policy across multiple levels to audit your entire Kubernetes cluster. And this is an example audit log, right? So here we have the level as metadata, and we want to, this is in the request received stage. So in this particular example, a user who's in part of the authenticated system with the username example@example.org is trying to list out all the services in the default namespace. And they're trying to fetch all of these resources from the source IP. And it also gives you the timestamp about when this particular request was received. So what you can start doing is probably start capturing all of these logs and push it to something like an elk stack, and finally start analyzing and have a good alert management system in place to raise alerts in case of any malicious behaviors inside your Kubernetes cluster. So when you're auditing your Kubernetes cluster, you want to know what pods are running as root. If any pods are running with privilege is equal to true. So we spoke about how Docker blocks 44 syscalls by default. By enabling the privileged true flag, it's going to allow all of those system calls as well. And if any of your pods are running with privileged flag, you probably want to know about it. If any of your pods have scary capabilities or exposed file systems, you want to know about that as well. And you also want to audit the system resource consumption of the pod that is consuming all of your resources. So we have an interesting tool right here called KubeAudit. So KubeAudit is an open source project by the Shopify team. What KubeAudit, first of all, performs multiple things, right? So it's going to check if you have resource limits in place. It's going to check if you're using the default service account token. If you've deployed pods or resources, it's going to go ahead and verify if they have been deployed in a secure manner as well. So we're going to run a KubeAudit on our Kubernetes cluster right now. And I'm going to skip some of these commands because we're running short on time, but I'm going to run the command KubeAudit all. So the way this is going to work is it's going to check for the resources, the network policies, the service accounts, the capabilities. So all of these things, KubeAudit is going to check on your Kubernetes cluster, and it's going to come back to you with a report. One of the interesting things you can do is you can create a JSON report out of this, and then you can start, push it to a UI interface somewhere, and then start looking at everything that is happening inside your Kubernetes cluster. So it's going to give me quite a few number of warnings and errors, and it's going to tell me that my Kubernetes cluster is running in a pretty insecure fashion. One of the other really interesting things about KubeAudit is it has a functionality called autofix. And the way this works is KubeAudit ensures that your deployment files are secure. So what I have right here is an insecure deployment configuration file. Right? So one of the things that you'll see right here is it's going to have the privileged is equal to true flag set to true. And ideally, this should not be happening. So in the shift left approach, before you even deploy any resources onto your Kubernetes cluster, you want to run a tool like KubeAudit and ensure that the specification file that you're using in your Kubernetes cluster is secure. So if I run the autofix command on my insecure Valflask deployment, it's going to fix some of the issues for me. And if I read that particular file again, it's going to drop all the capabilities. Privilege is now set to false. Allow privilege escalation is set to false as well. So it's going to run this, and it's going to make sure that this entire deployment file is as secure as possible. And that's going to be a challenge because this is going to be a little too secure for your application-driven function, right? So you want to use this as a starting template, probably remove a few things that are right here, and then run your deployment file. With that, let's look at vulnerability assessment in Kubernetes, right? So some of the potential vulnerabilities in Kubernetes is, first of all, insecure deployment configurations, right? So if you have not deployed, especially if you're deploying your own Kubernetes cluster, and if you have not deployed it in a correct fashion, the configurations can be challenging because there are a lot of moving parts. So we have seen instances where the etcd, the database or the data store that stores all the configuration files, have been exposed without any authentication, right? So there are a lot of challenges when you're deploying your own cluster. Then we have insecure containers and applications that are packaged as containers running inside your Kubernetes cluster. And finally, we have insecure third-party services. So if you're going to be integrating a lot of third-party services that have access to your cluster, you want to make sure that all of these third-party resources are secure as well. When it comes to your specification files, you have to make sure that you're not using sensitive information as part of your YAML resource, especially as environment variables, because we saw how easy it was to fetch some of these unencrypted environment variables. So try to have your own secret management system in place. So if you are on AWS or GCP, you can leverage their solutions. If you are looking for something else, open source projects like Vault or even Camus, for that example, is something you can use. In your YAML specification files, you can also have insecure networks, lack of resource limits, and privileged access to pods, and finally, extensive kernel capabilities inside your pods as well. So there is a tool called kubesec, and you can check it out on kubesec.io. And this is a more of a shift-left approach to check and verify that your deployments are as secure as possible. So the way this works is it's going to scan your configuration files for you. So even before you deploy all of these resources onto your Kubernetes cluster, you want to scan all of these resources using something like kubesec, and it also gives you a score, which is extremely easy to track. So once it passes a threshold score, only then have it deployed onto a Kubernetes cluster, right? So this can be extremely easy to integrate with as well. But one thing you have to remember is all of your specification file, all of this data is going to go to a third-party service, which is going to be kubesec.io. So you probably might want to obfuscate some of the sensitive information, like your image name, environment variables, and all of that, and only then upload it to kubesec.io and then fetch all of the information. So when it comes to cluster deployment flaws, there can be lack of authorization to the Kubernetes dashboard, the etcd, or the Docker API itself. And there can also be unencrypted or insecure communication inside your entire Kubernetes cluster. Insecure third-party services being used, especially something like logging servers, can be a challenge, right? So you have to make sure all of your third-party services are inside your Kubernetes cluster and they're not exposed to the outside network without any authentication or authorization in place. And we have seen instances where that has happened before. And finally, inadequate network policy. So with that, let's look at another tool called KubeHunter. So this is an interesting open source project by the Aquasec team. This is more of a pen testing tool and not technically a VA tool per se. And the way this works is once you give it the Kubernetes API, it's going to try and attack your Kubernetes cluster. So it has two modes, which is the active mode and the passive mode. So if you use the active mode, it's trying to change and mess around with the configurations. So you might not want that happening. So we are going to run a lab with the passive mode, right? So we're going to run the KubeHunter lab. So I'm going to list out some of the checks that are going to be performed by the active mode. So I'm gonna run this particular tool from a Docker container. So I'm gonna pull the aquasec kube hunter Docker image. And once this image is pulled, I can essentially point it to any Kubernetes API server, and it's gonna launch a scan for me. So these are the list of active scans that it's gonna check for. And here are some of the passive scans that Kube Hunter is going to check for as well. So now I'm going to run this tool on this particular Kubernetes cluster, right? So I have a Kubernetes cluster running on my IP right here. So I'm going to launch a Kube Hunter scan on that particular IP. So I'm going to run the Kube Hunter lab right now. So I'm going to tell it I want to scan a remote scanning. So I have a specific IP address that I wanted to scan. It's going to scan that, and I'm also going to give it the IP address, and it's going to list out all of the issues that have been found, right? So it's going to tell me that there's unauthenticated access to the API. As an anonymous user is able to list out all the resources and all the pods and all the namespaces as well. So this particular Kubernetes cluster that I've set up has been set up in an extremely insecure fashion. It's going to tell me where the etcd is. It was able to find my etcd database. It's going to tell me where my kubelet API component is running. So as an attacker, I can try and attack the kubelet API and then gain access to the Kubernetes cluster as well. So these are some of the attacks I can do. You can check out the Kube Hunter tool on Kube Hunter on their GitHub page. And finally, let's look at a very security specific Kubernetes CI/CD, right? So we are going to run a pipeline using GitLab CI. So in this pipeline, what we have right here is when you're thinking of security as part of your pipeline, you have to have multiple pieces that are attached to it, right? So as soon as I trigger a build, first it's going to scan my application source code, right? So it's going to run a SAST and source composition analysis on my application source code and all of the dependencies as well. So once both of these checks are passed, only then it's going to build my Docker container or my application container. So first it's going to run SAST and SEA parallelly. So once both of these are, all the results are fine, it's going to run my Docker build. Once the Docker has been built, I'm going to run a clear scan on my built Docker image. And I'm also going to run kubesec against the resource file, right? So I'm going to create a deployment on my Kubernetes cluster. So it's going to launch a kubesec scan on my deployment file, and it's going to give me back a score so I can check for a threshold. And finally, once this is done, it's going to deploy to my Kubernetes cluster. And what you can also do is you can implement something like Kube Hunter and multiple other scanners as well, right? So you can implement Trivy, Anchor. We have implemented Claire already. There's also a tool called Dagda. So in this example, we have our entire CI pipeline, and it's also going to deploy it for us. So since this particular pipeline usually takes a while, I've already gone ahead and run it a few hours ago. So I've run this particular pipeline 5 hours ago. And let's quickly go through the entire pipeline, right? So first it's going to run a SAS scan for me. I'm just going to open this up in a new tab. So once the scan is done, it's going to generate a report, which is going to be stored as an artifact. And then I'm running my source composition analysis. Once that is done, it's going to build my Docker container. So once my Docker container is built, it's going to be stored inside a private registry. So I'm not going to be storing this particular Docker image on something like Docker Hub or a public registry. I'm going to store it on GitLab's private registry right here. So I'm going to pull that particular image, run a clear scan on it. I'm going to run a kubesec scan on the deployment file, and finally it's going to deploy all of this to the Kubernetes cluster as well, right? So after every scan is done, it's going to give you options to download and browse some of the results that have been generated. So you can go ahead and look at the results of the tool. One thing you can do is start pushing all of these results to a vulnerability management solution so that you have, for every deployment, you have all the issues that were present. And with that, we've come to the end of our webinar, and I'll be happy to take any questions if some of you have it.
Thanks, Nitin. I know we're just closing in on the end of the hour, so I'm just going to quickly take a couple of questions. Alex, who just learning a lot of Kubernetes, he's been asking, what is, in your opinion, one of the most powerful features of Kubernetes? I know it's a subjective question, but what would you say is one of the powerful features of Kubernetes?
Sure. So getting started with Kubernetes can be a little challenging, but once you get the hang of it, it can be extremely easy to use. And the fact that there are so many third-party integrations and third-party plugins that you can start using, and you can customize and modify your entire cluster the way you want it to perform and the way you want it to operate. And this can be a huge benefit because every organization is different, and the way every organization implements their cluster or deploys resources onto their cluster is definitely going to be different, right? So the fact that there are so many options for you to play around with it is, and it's relatively easy to play around with as well, is a huge bonus.
Okay. And one more question is, what sets Kubernetes apart from other container orchestration frameworks vis-a-vis application security?
So there are multiple. So if you're using something like Docker Swarm or Docker Compose, those are typically for single, especially Docker Compose is for single server deployments. All the things that you can, security features you can use for a container can be used on Kubernetes as well. One of the key features is all of these security controls or all the security measures that you're taking can be scaled along with your cluster, right? So your entire AppSec can be scaled with your Kubernetes cluster itself. So with something like Docker Compose or Mesos, for example, if you want to implement AppArmor, you can obviously do that. But if you want to do it in Kubernetes for across multiple nodes, across multiple pods, it can be extremely easy to use. So the ease of use is one of the huge benefits.
Okay. We just got one more from Magno. In your opinion, what are the most critical vulnerabilities that can be found on a Kubernetes cluster?
So this can be this is an interesting question, right? So this is highly dependent on where your Kubernetes cluster is deployed. So if you're using something like AWS or DigitalOcean or Google Cloud, they mostly handle some amount of the security aspects for you. If you are deploying your own cluster, you have to keep in mind about all the security measures for all the services that are being deployed. At the same time, especially if you're using third-party services, so we have seen instances where one of our clients had implemented an elk stack and that was exposed to the public internet. So if you are deploying third-party resources onto your Kubernetes cluster, that is something you have to be extremely careful about, because more often than not, people use the default values and they go ahead and deploy it. And also, please try and follow AppSec 101. Ensure that your application is secure before it's being deployed to your Kubernetes cluster.
Okay. Yeah, I know we've got a couple of more questions coming in. Unfortunately, we're already out by 2 more minutes, but I know this is a lot of information to swallow in one go. So what we're going to do is, just like other webinars, we're going to record this. It's going to be on our online YouTube channel. So for all the other questions, please feel free to kind of put them as comments in there, and then Nitin or somebody from the team will get in and then answer your questions on that channel. Also, we're going to be releasing our online training calendar. So not just the Kubernetes training, but all of our other training programs for people who've attended our trainings and conferences, or we've done a bunch of them for of private trainings for some of our other customers. So we're going to be opening it out in terms of public virtual sessions, just like that we would do in classroom sessions. So what's going to happen is we're going to put out an online calendar. We're going to try and have multiple sessions, multiple classroom trainings in a month, so that the dates kind of work out for all of you guys. So if you're registered for our webinar, you will get an email notification as part of our from our team. But if you're not, be sure to kind of check into we45.com/workshops. You'll get a complete list of all of our workshops there, and all of them are going to be live with the cloud-based programs as well. So we're going to have all our cloud programs, cloud hands-on labs. We're going to keep them live even after the workshop, so that for people who are coming in who just want to play around with the cloud labs even after the workshop, that's going to be possible as well. So you should be hearing from us as early as next week. Follow us on Twitter and LinkedIn at we45. You will have all of this information. Again, once again, thank you all for joining in for today's webinar, and we look forward to seeing you in our upcoming programs as well. So have a good day, have a good night, and stay safe, everybody. Thank you.